Sodium chloride is a Na is a sodium that is a positive ion, and the chlorine is a negative ion. Between the sodium and chlorine is right to form a bond. It is a just ionic bond is right to form. This is a one of the sodium chloride bond. This structure of the sodium chloride is also somewhat different than the other. So it is a special category for the sodium chloride. It is a face centered cubic lattice crystal has to present. So for that I am going to draw a sodium chloride. How to draw it and everything I am going to explain now. So once you see here, I am going to showing as a, this is a big circle is called as a chlorine, Cl minus. Okay. So here once you observe that, then this is a thickness dot is indicating as a Na plus ion. Okay. So next one, it is a face centered. This is a face centered. Now I am going to show with a cross symbol. So because it is a face centered, so what is that? Cl minus ions are ready to present. I will show this one, okay, graphically how it will be ready to present. And now you can draw that like a box type of the 4 chlorine atoms. The 4 chlorines has to present. Okay, the 2 here and the remaining 2 I am going to draw here. So you can take as a small or bigger one. So circles. Right. Okay, here it completed. Next one, here I am going to draw a one more circle here, and here I am going to draw a one more circle to draw easily. Okay, so then next one, the equal height I am going to draw one more circle is here, and here also one more circle I am going to draw. So you can take as a somewhat small or below. Okay, so now you join the circles. How it will be look like? It is a just square. So here once you observe that, right, it should be one square, and here it will be one more square. I am going to say the position of the O is like this circle, right? So one more, and here also it's showing as a one more circle, somewhat it is. Okay, right. So then I am going to join this one, and here also I am going to join. Okay, so in this I am going to just draw, this is a one more line, and you can take as a just wait. Right. Here it should be, and here it should be, right? Now when I am going to join, because it is ready to show easily, so then it should be drawn like this. Then it is a joining of this. Now it should be look like a crystal. Here also we can join like this. Okay, so then easy to draw. And next one I am going to take as a in middle of these 2 chlorine atoms. So here I am going to show as a one sodium Na plus, and here also one sodium has to present. The middle of this one, the one sodium, and as well as here also 2 chlorines in middle. So one sodium, I am going to join this one. So here I am going to join. Okay, so then it is ready to join like this. The next, in between the 2 chlorines I am going to just join, again keep as a sodium, and here also one sodium, and here also one sodium, and here also one more sodium. Again I am going to join this one. So here it should be like this. Okay, so this is a one more thing. If I am going to take as a, again in between the 2 chlorine, again I am going to take as a one sodium, and here it is also one sodium, and here also it will one more sodium, and here also one more sodium has to present. Now I am going to draw the lines here, and it should be drawn like this. Okay, So that is a horizontally we can make it. Okay, once you see here in this situation where it is right to meet, and here this is a face centered the chlorine atoms. So cross I am going to keep as a symbol is a cross I am keeping. So too easy to identify. Okay, and here also it will meet point now. So this is also cross, and where this is also meeting point I am going to take as a cross, and here it should be completed. Now I am going to join this one. See here it should be ready to join these two lines. So what is that? Again it is a middle point is there, it should be chlorine. Okay, so in this we have to identify that once you observe that this is a face centered, and here also it should be ready to present. So once you see here, this is also one of the face centered, here also one of the face centered. Now you can join these lines. Okay, so once you observe that, for example, one chlorine is just having the 1 2 3 4 5 6, that each and everything is covered with a 6 elements. So one sodium is having the 6, that's why there is a number of the sodium chloride. That what is the face centered means, that is a 6 chlorines are right to present around the sodium. So this is called as a face centered cubic lattice crystal. So the covalent bond, who given this a covalent bond? Previously we know that there is ionic bond is there. The ionic bond is nothing but there is a sodium. For example, the sodium is having the positive ion and the chlorine is a negative ion. It will right to share. The one is a positive and another one is a negative, means both are right to make a bond. That is an ionic bond we discussed. Now in this covalent bond, what we need to discuss means, if that Gn, who given the covalent bond means Gn Lewis. So here Gn, okay, so Lewis. So in a 1916, okay, in the year there is a 1916, he proposed this kind of the covalent bond. So what is a covalent bond means? In that, for example, one atom so contain that electrons, so it will ready to attract the other electrons, means that is a one atom is ready to make a bond with a other one. So this is ready to form a in a octet rule. Octet rule is nothing but that is the outermost shell is containing that 8 electrons. So here it is ready to make a bond with a other element and make it as a octet configuration. So here there is a dissimilar, the elements are also ready to form a octet rule and try to share the electrons with a one atom to other atom or one element to other element. So in this is a covalent bond, for example. So what it will be, there is a F2 molecule. The F is a fluorine is a, we already know that there is a F2 molecule is there. So I am going to show this example molecule. I am going to show that F2 molecule. Once you see that F2 is a configuration, fluorine is a, what is that, 9 configuration. Okay, so then what is the electronic configuration for that? The atomic number is a 9 and electronic configuration is a 1s2 2s2. So what is that? 2p. So 4 completed. Okay, so 2p5. 2p5 means that in that particular I am going to show the structure of the particular fluorine, s orbital, and this is also one of the s orbital. I am going to show as a p orbital is like this, means 3 subshells are right to present. So in that s orbital, how many electrons are right to fill? The 2 electrons are right to fill. That's why it should be 2 electrons. Here also 2 electrons are that s orbital, but the p orbitals, what is that? It should be the, so 2 electrons, and here also 2 electrons, but one is a lone electron, means unpaired electrons are ready to present. So it needs to ready to transfer, it is ready to make a bond with a another fluorine atom. So then how it is ready to form? So fluorine, according to the Lewis dot structure, it will be showing as a 1 unpaired electron. This is a paired one and this is also paired, means the 4 completed and 6 completed. Okay, 2 plus 4 plus 2 is a 6. So really how it will contain in that, the valency means there is a second shell is a valency, total 7 only. 5 plus 2 is a 7. So I need to show that the 7 means 6 completed. So where is another one? It should be, there is a lone electron. So here there is a mixing with a one more fluorine. It should be containing as a 1 lone and remaining is a paired electrons. Then it should be ready to make a bond with a 1 fluorine and another fluorine 1 electron. So then here the fluorine is having like this. Now it should be make it as a bond with a other fluorine. Now it should be called as a, that is a single bond. The pair is a single, so that's why the single bond fluorine atoms has to present. We can write another one, another formation also without using as a dots. I am going to show as a line. 1 F dash 1 means, sorry, F dash F. So one line is indicating as a single, or there is a first, sorry, the only one bond has to present. Okay, so then we'll go for the another example. So in that O2 molecule, this is another example of a covalent bond. The two oxygens are ready to share a electrons and make it as a bond with a, so covalent bond is ready to form. So I am going to draw the structure. First of all, before going to to draw the structure, oxygen is having the atomic number is a 8. So here I am going to write the electronic configuration, 1s2 and 2s2 and next, so 2p4. So here once we completed, there is a 4 electrons and here also 4 electrons are ready to present. In this situation, if I am going to show the structure of this one, so this is a s orbital and this is also one of the s orbital, 1s and 2s orbital, and next one is giving as a 2p orbital. Okay, so 2p orbital. In this, the 2 electrons are filled, and here also there is a 2 electrons are filled, but in that particular, the p subshell is nothing but p orbital. There is a first one is a 1. Okay, so next one is a 2, and here there is a unpaired electrons are having the 2 electrons are ready to present, means it needs 2 electrons to make a bond with the other oxygen. So then I am going to show the Lewis dot structure, that is oxygen is having their outermost shell is containing how many electrons in it? There is a 4 plus 2 is a 6 outermost shell. So that's why, so this is a 2 and this is a 2. Okay, 4 completed now, and here it is a lone, one is a, so unpaired electron, here also one more unpaired electron is ready to present, is mixing with the same as it is again. So the remaining all are paired electrons. So this is a bond with another one, and here also ready to make a bond with this kind of the pair electrons. So that's why what I am going to write, that this is a oxygen is having the, oxygen is having the, what is that, there is a 2 and 4 has to present. The bond is pairs of the electrons has to present like this. Okay, so how many will be there? This is a pairs, the 2 pairs are there, means that is a, so double bond. The first one is a nitrogen is this, sorry, there is a fluorine is a single bond and oxygen is a double bond. I am going to write here that is a oxygen is a double bond with a one more oxygen. The 2 lines are showing as a double bond, right? So here there is a nitrogen molecules, N2 molecule is also there in that example of a covalent bond. There is a N2 molecules means there is a valency of a nitrogen is containing that in a, so 3 unpaired electrons are ready to present the valence shell. So I am going to draw the diagram here. So nitrogen, the nitrogen atomic number is a 7, all we know that. Okay, so it should be, what is the electronic configuration? 1s2, 2s2 and 2p, so 3. So 3 electrons are there in a p orbital. I am going to draw the structure. So s orbital, and it is also s orbital. Now it should be ready. So p orbital. So once you observe that is a 1s and 2s and it is a 2p. So s orbital is filled with the 2 electrons, and here also 2 electrons are right to present, but it is a unpaired electrons are right to present is a 3 electrons in a p orbital. That's why it's a 3 electrons we need to make a bond with a other nitrogen element. So here according to the Lewis dot structure, again I am going to show that it is a, so 2 valence shell, how many it will contain? There is a second shell is containing that 5 electrons. That's why, so 2 and completed. So here it should be 1, 2, 3 is a unpaired electrons. The 3 electrons are not paired. That's why it should be, so separate I am going to draw. And here there is a one more nitrogen is also same as it is. Then this element or this electron and this electron is also right to make a bond with each other. So then it will be make it as a triple bond. So nitrogen is having the 3 bonds are there, means 3 pairs are there in between the 2 nitrogens. So here it should be ready to 3 nitrogens, means nitrogen is having the triple bond with a nitrogen. So this is a triple bond.